Hello, everyone. Today I want us to talk about how to write mathematics in LaTeX. So we have a lot of mathematical symbols, and we might need to write them in LaTeX, as given that our course is in mathematics, then we are bound to writing in mathematics in LaTeX. So to begin with, let me just start by calling the document class 12pt. We can use article, then begin document. Okay, so let me save this as class 2 in the same folder. I don't need to include .tex. That will be done automatically, as you can see here. Okay, so let's start with something we call inline math. Inline mathematics. So we're going to have several mathematics environments. Basically, we have two major mathematics environments, that is inline math and display math. So let me give you an example of an inline math. So this is an example of an inline math. And this is an example of a display style math. All right. So in LaTeX, you have to know that whenever you press enter, this sentence belongs to the same paragraph as this one. So this will just be a single space in the output in the PDF document. But when you press, you leave an empty line here, it means this is a different paragraph and this is a different paragraph. So I'm going to input some inline math. So in order to write an inline math is supposed to be between just a dollar signs, a pair of dollar signs. So what comes in between will be in inline math. We can also use backslash and opening parentheses and backslash and closing parentheses. There's something you should note. When I start a math, everything following the opening of the math is green until I close it. So this means whenever I open any math environment, I must close it. Whether it's a dollar sign, I must close it with the dollar sign. And then the green disappears. When I leave it like that, you're likely to get an error. Not likely, you're definitely going to get an error of missing dollar. You see missing dollar inserted, line 9. Most of the time is not necessarily the line that you expect. Just look around, okay? But this is line 9. You can see this started math environment, but we did not close the math environment. So we obtain an error. Anything in mathematics, let me just write something like f of x equals x squared plus x, 2x plus y plus 7. So you should note that this power sign is used for raising these two to power. That is a superscript. So this is found by pressing shift and then 6. You will obtain this power sign. Simple. So that is an example of an inline math. We will see the difference between inline and display style math. So display style, we're going to use double dollar. We can also use something else, but let's see what double dollar gives. Let me increase the percentage to around 125. I don't know. It disappeared. Here it is. So this is an example of an inline math. Let's see how it looks like. And see that you note the difference. This is within the same paragraph as the normal text, but this one is centered. And the font of this one is usually larger than the font of this one in most cases. You will note as you continue doing some practice. So this is what we call the display math, and this is what we call inline math. I hope you can see clearly the difference between the two. Okay, so we have display math. We can use the square bracket instead of, so opening bracket, and to close you use a closing bracket. Here you can use opening parenthesis, backslash, closing parenthesis, and then we're going to get the same thing. It's basically the same thing. So we can use this for inline math, and we can use this for display style, or use double dollar and single dollar. So once you start with the double dollar, you must end with double dollar. Fractions. How do we write fractions? So let me just include the fraction here. Let me make this something over something. So suppose I want to write this over something else. I'm going to write \frac is a command which takes two arguments. So that is the first argument, and the first argument is the numerator. Now the second argument is the denominator, which we can say x minus 2 something. Let's see what we have. So as you can see here, we have some kind of a fraction. This is the numerator, which was the first argument, and then the denominator, which took the second argument. That's a simple fraction. I don't think you need some complicated fraction. You can have fraction on top. Like, let's say this is x squared over 2, or this is 7 over 5. Let's say fraction here. So again, you have to insert a fraction inside there. And then you have to do the same. The first argument is the numerator. The second argument is the denominator. And when you run it, you will see that this is also a fraction, 7 over 5. We can also make the second one a fraction. And let's see if we can notice any difference between the two in terms of fonts. So as I said, this one usually gets bigger fonts than the inline style. As you can see, this one looks very small, and this one looks just normal size. So that is also another difference of inline and display math. What about an underscore? For example, suppose this is x1 squared plus 2x2 plus something, just a way to write an underscore. A subscript, that is, a subscript. In order to write a subscript, we need to use underscore. So for instance, let me just carry this one here. Yeah, let me retain this. So this is an example of subscript. So I'm going to have x underscore 1 plus y squared equals 7. This is just an example to show you how the subscript works. So this is x1. You can see this is the one is a subscript. The 2 here is a subscript. But there's something else that you need to know, how to do grouping of letters or digits. For example, suppose I write x underscore 11, and this is y power 12. Let's see what will happen here. So you can see, you can note that whatever it is that we wanted to write is not the same thing that appears. As you can see, this is x1, 1 plus y power 1, 2. But we wanted to write y power 12 and x 11, something like that. So how do we group? We use braces. So if you want the whole of this, if it's more than one digit or letter, the best way to do it is just by using braces. The same way with the power, and you will note the difference. With the power. Now this has been grouped as one and therefore will be raised as one thing. And you can see the difference. This is now x11 and y power 12. So note that as you do your practice. Let's see some other mathematical symbols. So I'm going to select all the PDF probability distribution function of continuous. I'm not sure if this is correct for continuous variable, whatever it is I'm going to use inline math, f of x equals to 3 or 2x. Okay, so we need to check whether this is a probability distribution function. But let me say something, comma, for 0 less than x less than 1. Okay, and is 0 elsewhere. So to check whether f of x, whenever we're writing math, we must use a math environment like this. F of x is a PDF. We integrate as follows. So here now we can use now display math. So we're going to say int So int stands for integral, the integral sign. Underscore means the limits or the lower limits, and upper limit is going to be 0, 1. We're integrating from 0 to 1, f of x with respect to x. In most cases, this one is used as inside a math room, what we call math room. The D is used inside what we call a math room. So I'm still writing the same thing, so I'm going to repeat the same thing. But why should I repeat when I have it? So I'm going to pick the integral from 0 to 1. F of x is 2x, I think. Then math room dx. And this equals to, as you can see, this equals to what? X squared, correct? Now we can say x. Let me just write the normal, the formula that we use. Plus 1 is a fraction. Divide by 2, right? I think. Right, 2, and this was 2x. So that's the integral. And then range here, I'm going to write something big here. You will see what that is. Underscore here. So this vertical line is found by clicking shift, holding shift and then pressing the backslash. I think most of the keyboards is usually together with the backslash. So this from 0, to 1. Let's see what we have so far. Let's see what we have so far. So we have something interesting here. The integral, as you can see, it's nicely written. One advantage of LaTeX is the symbols are nicely written. So this is what we were doing by using that vertical line there. And we have used the big one. If we just use the small vertical line, a normal vertical line without using that big with double G, and then we would have a very small vertical line here, but I wanted a big one. So that's how we do these things. So I'm going to continue writing that equation, and then you see what we have. So this equals to, I think, x squared from 0 to 1, and that equals to, I believe, equals to 1 minus 0, which equals to 1, and therefore that's a PDF. So that's how we write math. Appears very nice. Looks nice. So that's how we write integral. So the following sentence is not going to be related to this, but it's just going to show you how we write summation. So suppose something that was what? Suppose I want to do some discrete that gives us summation. Oh, let me just given. So I want you to note the difference between inline summation, and also integral. It's going to be different when you use inline and display math. You can try the one for integral. I'm going to give you an example of one for summation. So summation from x equals to, or I equals 0, 2. So you can see I'm also grouping something because it has more than one character. This one is to 2, so we have just one character. So there's no need of grouping it. But suppose we were writing to 22, we have to group it like that. So I'm going to write xi underscore I. We can plus I squared, just to write something, or maybe xi squared. So we can start with the underscore. If it's x underscore, if I is the subscript and 2 is a superscript, we can start with either of them. We can start with power 2 and underscore I, or start with the underscore. Either way, it's going to give us the same thing. So we need to close that. We need to close that environment and see what we obtain. Let me just add and display math. I'm going to copy the same thing, copy, going to paste it here, close the display, and let's see what we have here. So as you can see, for inline, the summation is kind of squeezed to fit in that line, but this one is given all the space that is required. So sometimes we need to write equations that have some kind of numbering. So in order to do this, I'm going to copy what we have there, and then before we go to numbering, we can have something like a series of equations, like for example, now consider the following simultaneous equations. So I'm going to have, now here we're going to use what we call equation array environment. So equation array, we're going to do some kind of alignment to, and to do alignment, we're going to use that unsign, which is also referred to as the alignment tab in LaTeX. So when you use this sign outside here, you're going to get an error because it's not aligning anything. So it's usually used for alignment unless you, it's what we call a special character. So we have several special characters. We will look at those at some point. But for now, let's focus on this equation array. So I'm going to say 4 equals x plus 2y. And that is the end of the first equation. I'm going to use double backslash to mean that that is the end. 6 equals 2x plus a y. Sorry, 2x plus a y. This alignment tab, as you can see, is after the equal sign. So that means this and this part will be aligned, on the same vertical. Like you can see this, there's this kind of an alignment. And as you can see, you have some space, which doesn't look so nice. So let's take it to this point here so that we can align it before we write anything, so that it looks a bit better. Now this looks nice. And as you can see, we have some kind of numbering. So this is equation 1, this is equation 2. We can, yeah, okay. So that's it for now. The rest we'll look at them when we're doing cross-referencing. But for now, let's just get satisfied with that. So that's how we align several. We can have as many questions as possible. So the alignment will be done. We also have an equation environment. So I'm going to have this as put under equation environment. So we have begin equation and end equation. So whenever you begin an equation, you must end an equation. So that's and a question environment and a question array, you don't need to use those dollar signs or anything else. As you can see here, we did not use dollar signs, but because this is a math environment by default. So equation environment also they are math environments, so you don't need to use a dollar signs. And you can see this now is numbered. So you can see we have some kind of numbering. It's still display. So all these are also display, but we are having some kind of numbering. Okay, so you can note that. I also need to mention something we call cases environment. Cases environment is used inside a math environment. It's not a math environment, but it's used inside a math environment. So I'm going to discuss three types of these cases environment. So personally, I prefer, but that depends on what comes after. Let me give you an example so that we can talk about something that you can see. So I added something here. Let me just run this, and then we can see what cases environment is all about. So this is what we call in cases environment. And what I was mentioning is that whatever you use depends on whatever comes after this part, what comes here and here. So if most of it here is text, then I prefer to use the cases star. You can use anything, but it will produce almost the same thing, because this one, as you can see, this one, I've used 3 different types of cases, these ones, but they look the same. They are just similar. This, I did not use cases. Here I used a line, so you can use a line here. You can use a line in this one. So let me go back, and then we can start by writing the cases environment from scratch. So let's suppose we want to write these things. So we're going to say, so number 1, I'm going to say, so number 1 is going to be what? Cases environment. So let me just use cases. So text BF means we are using bold. So this is going to be bold. but we can use something else here, which is a bit easier. So by using BF inside this group, so we are grouping, and then inside here we're using behave. We can use EM for emphasis. So it's going to be in italics. So let me copy that. So the first one is going to be cases. The second one is going to be D cases. Cases, D cases, and what? D cases, star. Okay, so let's start with, so this is inside the math environment. I'm going to use the display math as usual. You can see this display math. You can only use this in display math, I believe, but I've not tried in inline. But it doesn't make sense when you try in inline. So I'm going to write f of x equals, then now I can begin cases. And whenever I begin something, I must end it. So this is an environment called cases environment. So that cases environment is used inside math environments. So you can see we've used this to define our math environment here. So the first thing here is x squared. So I'm going to write x squared, comma, and then the alignment tab. So here, so that we can align this part here. Now the following part is text. So if I write when x greater than 0, then I end that part. As you can see, it ends there. And then the next part is 2x, comma, otherwise. So that is what we have now. Let's see what we obtain when I run this. Oops, we are getting something like misplaced alignment tab. So it doesn't understand what cases means. So in order to use this, we must use a certain package. So let's use package ArmsMath. So I'm not sure whether it's ArmsMath, but I'm suspecting it's ArmsMath. As this, yeah, it's ArmsMath. So that is what was lacking. You must know where your errors are coming from. So this is what we have. So as you can see, this does not look so nice. Something is not right here. So we need to work on it and see what happens. So I know the error, the problem with that. So this, I'm going to make it a text. And up to that point. So I'm leaving this space out for some reason, because if I don't leave it, this and this will be joined. That is not what I want. I want some space when space x greater than that. And also I'm going to make this text. There's also something else that we had forgotten. And that was, you don't need the space. That was, as you can see here, the alignment. You see, it's aligning it here by default, but we need to align it together with this. So before I write otherwise, I'm going to use the alignment tab. It's here. So let me just push this down here. Okay, just no problem. If I run it now, I'm expecting something a bit better. So you can see something looks organized. Now let's try with, let me number this one. We can, okay. Let me not number it because you have to get used to some other type of numbering and numeration, which we also look at some point. Now I'm going to use decases, and decases. So decases and cases. Oops. No, I know the problem. So it's saying that the environment decases is undefined. This simply means that we need to call another package. So whenever you get some kind of an error that something is not defined, then it means it's either not defined or you're missing some important package. So I can use a package here, math tools, but you need to install math tools. I think when you run it, you need to have some bundles so that when you run it, it will prompt you to install the package, or you can simply write it here, math tools. So you can use it either way. You can use it independently, or you can just use it together with the other packages. You can just load them together. So now, as you can see, we have obtained something here, which is also similar to what we had. So that's number 2, which is the cases. Let's see the cases down. Now you will see a difference. Now this and this can be used the same way. And I also think that you can use, when you use math tools, you don't need to use ARMS math. Let me check. Yeah, when you use math tools, sometimes I don't think you need to use ARMS math. It's a bit superior, is a superior style file. So we were doing the last one, which is the case system. So a star, I'm going to use the star there, the cases star. Now let's see when we run it at this point. So what do we have here? Here, we are getting something weird because it's seeing these as, you can see this x is not the same as this x. And this now is not being understood, the greater than sign. So when we working with dkc star, it assumes that everything that comes after that is a text. So you don't even need that text that we included there. But now that math has to be inside some math environment because it assumes that what follows that is text. Then you have to insert some math environment here so that it understands, it reads that as a math environment, as math. So this 2x, what follows this is seen as text. So you don't need to write the text there. And you can see everything turns out nicely. So let's see when we avoid using this inline math environment there. So you can see it doesn't see this as mathematics. So you need to use the $sign for inline math. So the last thing that I need to mention is matrices. So let's go the first section, mathematics, intro, something like that. So we have two sections here. The first section is mathematics intro, and we have another section which is matrices. So I'm just going to give you one example of matrices. So consider the following matrix or matrices. So again, matrices are environments that are supposed to be inside the math environment. So I'm going to give an example by using a 3x3 matrix. A equals begin P matrix. So you can use a matrix without P, and we need to see what happens there. So I'm going to use one and. So and this alignment tab again is for alignment. What I mean is that this is the first row, first column, second first row, first second column, and third column. You end that, you go to the second row. You don't need to press enter, but I like to press enter so that we have some kind of uniformity. You can see exactly what you're writing. And then 7, 8, 9. So that's an example, but you need to use a math environment. So let's see what we have when we don't specify the kind of matrix. So we have some kind of an alignment like a matrix alignment, but it doesn't look like a matrix, doesn't have the brackets. So that is one. So I'm going to copy this. Another one, P matrix. So P matrix, so where P stands for parentheses, so the bracket that you expect is the bracket, the parentheses. This is the parentheses, so that's a parenthesis matrix. Let's try another matrix. Is what we call a block matrix. Let's use B matrix. So I'm going to use a B matrix. So B matrix, as you can see, we have a block, a square brackets. It's a block. Let me copy this once. This we can use as capital B. We can also use V. And then let's use the last one, which is going to be capital V. And let's see what we have. So these are different types of matrices that you can write in LaTeX. A small v. So you can see whatever is inside is just the same. The only difference is the environment name. Whatever is inside just written the same way. So these are the different types of matrices that we can write. So this is the B, capital B, we have braces matrix. Small v, we have that vertical for determinant. And V, we have the double for norm. So that will be all for now. See you next time.